Okay, good evening, everybody. Where we stopped last time was we will get started with Oracle built-in functions. There are a lot of functions, and these are very useful, basically for extending existing code. Oracle already provides tons of functions, and these are useful when you use it with your tables and your data. So just to get started with the functions, basically what we'll do is we'll first look at the null value function. So you know that in database, if you don't have a value, you insert null. And let's say, for example, you will say select null from dual. And we talked about dual table. Dual is a table provided by Oracle system, and it always returns only one row. So here you can see I'm selecting null and it gives me null as output. Now, what if you want to get you want to compare a given value, and if it is null, then you want to show, let's say, 1000 as a value. So you can use this function called NVL, which is a null value function. First parameter is to give a value, and then you'll say what is the replacement if it is null. So let's take another example of NVL function. Let's say value is 500 or 400. If the given value was 400, if the given value was null, then replace it with 1000 as output. So now if you run this, I will explain what is happening here. First thing, you're requesting it to just give me null, right? It is giving you null in the output. Now in the second one, you're saying my input value is null, and if it is null, this NVL function will return whatever is the replacement value you provided. So NVL function takes two parameters. Now here you're getting 1000 because the input value is null and your output is 1000, the replacement value. Now in the third case here, you're saying null, if at all the input is null, and then you will want to replace it with 1000. So here input is 400, which is a value. So it is returning 400 without replacing it with the replacement value for null. So you can use this null value function on any table you have. So let's say, for example, if you say a select star from EMP, what we'll do is run this query, and you see there are several places there is null in the commission column and also manager column. Now, NVL function can be applied to character data type, varchar data type, date data type, or number data type. In this example, we are just using number data type. Now, what you can do is, say, for example, you want ename and commission. And let's say, for example, now, if you run this query, it just shows you enames and the and the data from the commission column. Now, let's say, for example, instead of commission column just coming back as null, what we can do is just for display NVL of commission column, and if it is null, then replace it with 0. Or let's replace it with let's say, for example, minus 99, just to show you what is coming back as an output. Now here, if you see anywhere you see the null value, it will come back as minus 99 because that is what the replacement value you provided. Okay. So mainly what we are trying to understand here is how to use Oracle provided built-in functions. NVL is one of the functions. And what it does basically is your input, whatever you're providing, if it is null, then it will replace it with the replacement value. If the input value you're providing has a value like 1400 here, it will not replace it with the replace value. It will just provide whatever is the value. So wherever it is null, it will replace it with the replacement value. Now, instead of querying commission like this, you can directly query ename and NVL of commission. And you somehow know that wherever it is minus 99, it is actually null value which is stored inside the database. So here it is only for display purpose. The function we are using is to get a value instead of getting a null value. Wherever the null is there, it will replace. Wherever value is there, it will just return the original value. Okay. So Now this is just an introduction to one of the built-in functions. There are tons of built-in functions. There is one very important function called okay, let's jump into numeric functions. Let's take a look at all the numeric functions first, and then we'll go into several other functions and then come to decode function. So let's start with numeric functions. Now that you know null value function can be applied to anything like characters, dates, numbers, everything. Whereas number functions, they work on numbers or numerics or decimals. So what we can do here is, first of all, let's do a power function and a square root function. So let's say, for example, select, I will say from dual, and then I will build out all my columns. Columns I'll put here. So power 2, 2 power 5, let's say, or 5 square. Let's find out 5 power 2. Okay. And also in the same way, you can write sqrt function, square root function, and square root function you can say 25. What is the square root of 25? Okay. So let's just run this. And what happens here is you see the power function takes two parameters. First parameter is what is the base value, what is that you want to raise it to. So this is nothing but 5 square. And what happens is the result is 25, 5 power 2 equal to 25. And then square root function takes one parameter. And what it does is it gives you back the square root value. Here you can do a lot more complicated stuff like say power of 10, power 40, 45, or whatever that big number is. And then you can do like say square root of some odd number like 675 or something like that. And then basically it will return you if there is a decimal value. You can see here this powered the 10 power 45 is a big value, and also square root value, you can see that it's a big decimal value output. So these are some of the number functions. Basically, they take numbers input and they give you return as numbers. And these are more like mathematical functions you can use. So one of the example is power and square root. There are other functions we'll explore in the numbers area. Let me know if you have any questions. But right now, what we'll do is we'll look at some more examples here. Let's say, for example, sign. Sign will tell you you have to provide some value, like say, for example, some number. And let's say I will provide a minus 99 and also sign of 99, let's say. There are three possible combinations of this sign function. What it is going to tell you is what is the sign of the given number? Is it a negative sign? Is it a positive sign? For 0, it should not give you anything, and generally it is treated as a positive sign. So let me just run this and then explain the output. So when we gave a 99, it is a positive sign. There is no symbol here, or sign is positive. So you can see that it gives you +1 is the output. So whenever it gives you one output, that means it is a positive number. Whenever it gives a -1, that is a negative input. Whatever you gave is a negative input. The sign is minus. And for 0, it generally returns 0 because there is no sign. It's a neutral number. So here, output, whatever number you give, whether it is big or small or decimals, it depends on your sign of that value input. It always gives you a 0, -1, or a +1. So this is how you can figure out if the given value is a negative or a positive. Okay, so this is another useful number function. This is very useful if you're calculating, like say, financial stuff. You're calculating how much interest to be paid, and then you can figure out whether it is a negative payment or a positive payment kind of stuff, or it is neutral. So sign is a very important function used in mathematical functions, or even in finance, it is very useful. Okay, so let me show you another mathematical function called ceil. And also there is a function called floor. So what we'll do is we'll take a couple of functions here. ceil and floor, and then explain what these things are. Let me take a decimal here, 24.5, and also let me write another ceil of 24.2 or 3, and then I will write a ceil of 24.8. Okay. And then what I want to do is I will take similar values, but I will do it with floor now. I will say floor, and I will just replace this function ceil with floor, and I will explain what is the output when you run this. Okay. So first thing is we'll take a look at the ceil function. Okay, here there is a comma missing. That was the error. So let me just run it again. Okay. So what I want to explain here is when you say ceil, you're asking for the next possible integer value. When you run this, it basically rounds. So what is the ceiling of a given decimal number? So it rounds it to the upper value. What is the next possible integer value? So you can see when you ran the ceil of these three numbers, it basically rounded it to 25. Okay, all three numbers became 25 here output wise, because whatever is the 24 point decimal is, the next possible integer is 25. Same way you're asking for floor, which is you're asking what is the previous possible integer for a given decimal number. So this will give you, let's say for example, you don't want to round, you want to basically ceil it or floor it. Basically you want to find out what is the integer value, possible next integer value. This is also very useful for doing mathematical calculations in terms of financials. You don't want to send a decimal value to customer. You just want to say what is the next possible integer or previous possible integer. You can do a ceil or floor. You can think of ceil as a ceiling of the room and floor is a floor of the room. And you can easily convert any given decimal in your mind to a ceil or a floor. But when you're writing code, you can use these functions to calculate your financial calculations. Now, what is the difference when you do this compared to round or truncate? Let's see round and truncate now. So what we'll do here is round of some numbers, like say 24.5, and I will take the same example of 24.5 and round 24.3, and then let's say round of 24.8. Okay, so when we do this rounding, what will happen is it will round it to next possible integer or previous possible integer based on the decimals. Okay, so it looks like it is doing 24 or 25 based on this. See, if you look at the mathematics, what we used to do is if the decimal is close to center, you will just take the next integer, or if it is less than half, then you take to the previous integer, and if it is more than half, it is next integer. So it is doing accordingly. But most interestingly, what you can do with round is you can say, for example, in the financial world, when you're looking at stock market, you might have a long decimal like this, and let's say for example like this. Okay, and also decimals here could be long like this. Now when you round this, you see what happens is by default it is going to round for a integer value. Now let's say in financial world you don't want to round it this way, you want to round it to 4 decimals. Then what you can do is you can specify how many decimals you want to round it to. And also let me run this for a second. I want to see if it works that way. Yeah, it works. And then let's round this to 4 and round this to 4. And you can see how it rounds is it leaves 4 decimals after rounding if you give the second parameter. Now what we are doing here is there is a huge large number in the financial world, and you want to say round it to how many decimals. So let's say you want to round it to 2 decimals. So it will accordingly round the given input into 2 decimal rounding. So round is very useful. Now what you did with the ceil and floor is you always got output of integer value, but round is very interesting. If you don't specify the second parameter, it always rounds it to 0 decimals. Otherwise, it will make it whatever decimals you want, like the decimals you specified here. Okay. So that is a very interesting way it does. See, if you notice, the second input we gave is 0.356, and based on 6, it is going to round it to 2 decimals. It will make it 0.36. What if we don't want to round it, but we just want to get rid of extra decimals? We just want to remove the extra decimals and keep only 2 decimals. So what if we don't want to round it? There is another function called trunc. So let me show you example of trunc. First, what we'll do is we'll keep this copy, and also we'll say truncate. Okay. Or actually it is not truncate, it is just trunc is the function name. And then you can say trunc here. Difference between trunc and round is trunc is going to just truncate, and round is going to round based on how many decimals you need. So let's just run this for now, and I will explain what it is doing. Actually, we should have kept the round output so we can see, compare it. Okay, so now I'm running both trunc and round for the same numbers. And what I want to show you here is I'm giving a big decimal here, and I'm telling keep only 4 decimals. That means keep whatever is there and ignore the remaining decimal points. And also don't do any rounding for that. You just truncate, remove the remaining portion of the decimals. And you can see here, like it is going to drop all that and give you a 24.35 as the output. And same thing when you did a round, you can see it gave you 24.36. Now, depending on your requirement, you can do a round or a trunc. But what I'm trying to show you here is there are 2 nice functions you can use, and also you can specify input variable. I also want to show you something here with the trunc and also rounding. What we can do is we'll take a large number like this, and let's just take a 5 digits so we can read it. Now also I'll make this 2 here, let's say, and I will copy this to the other numbers. Okay, so what I want to show you here is there is a the second parameter here we are using only affects the decimals, right? It doesn't do anything if there is no decimals. But in Oracle, what you can do is you can pass a negative value for the second parameter, and I want you to observe the behavior, what it does. When you do that, basically it is going to round. Let's say, for example, I'll give this 80, 82, and also I'll copy this and make a 82 here. And also I'll take this and make a 42 here. Okay, so I'm just taking exactly same numbers, but I'm doing a round and trunc on these numbers. Only difference here is the second parameter, I'm taking it as a negative number. So when you give this negative number, what it does is basically it truncates or rounds based on what you provided here. It now you're actually telling it to round it to hundreds position. So it takes this number and rounds it. So because it rounds it, it is less than 50. So it is basically making it 500. But here it is 82, which is more than 50. So it is making it 600. With the trunc, basically all you're telling is you just truncate 2 positions. It doesn't matter what is the numbers inside that. It just makes them zeros. So you can see that this is a very powerful function where if you give a positive number, it is going to act on decimals. If you give negative number, it is going to act on the integer portion of the whole thing. Now, you can also try to give some decimals and see what happens with a combination of stuff. It basically removes all the decimals and it just rounds. And here, if you do the same thing with truncate, it is also doing the same thing here. So remember that you can use it for both decimals and the integers, and also try these functions so on different numbers, so you'll figure out how they are reacting to each scenario. Okay, so these are round and trunc functions. Now also remember that these are all working on numbers, and you can apply like the input is this column, so this column can be like a salary column, so you can round the salary. And let's say for example I will say salary column round it, and you're actually selecting it from employee table, and instead of rounding it this way we'll say round it to salary, and hundreds position you're rounding. So you can see this output. Here it is 2850, but you're rounding it to 2900. And you can apply trunc also same way for the columns. And you can see here you're taking a 2850 and then truncating it to 100 position. And you can see 2800 is the output. So only difference is previously I was just running it from the dual table, which is just a calculation kind of thing. Here it is calculating, but input is taking from the employee table. Okay, so those are like round and trunc functions. Then there is another function called greatest and least. This is not very useful, but what you can do is there are some bunch of numbers in your finance table. You can use that. I will just show you example. May not be great example for this, but greatest is one function and also least is another function. What these things do is they take numbers and decimals, whatever. Okay, so let me just type some numbers in random order. Okay, and what we'll do is we'll run a greatest on this and least on this, and you can guess what it will do. It will just tell you what is the greatest number, what is the largest number. Oh, remove this EMP actually. Dual, run it on dual, so that way you get only one row output. Now, if you see the greatest, I just provided a bunch of numbers and I'm asking what is the greatest number, what is the maximum number inside that list. And also here I'm giving the same numbers and I'm asking what is the lowest number inside, which is the least function. Now, this is not useful in the sense you cannot say, for example, select greatest of salary, because that's the only one column you're providing, and greatest of sal and least of sal from EMP. Now this is not going to behave like you expect, because uh, here what happens is each of these functions is actually thinking of getting a list of things. Here you're providing only salary. So instead, if you say commission, then it is going to compare between salary and commission in each of that list, and it will tell you what is the greatest and least. Um, Remember, most of the time, null, if you use it in your mathematical function, that null will become a null. Basically, returns in null. If you add something to null, it will return in null. Multiply something with null, it will become null. These are very useful in the sense like, most of your mathematical functions are useful when you're doing mathematical stuff on your financials or salary calculations or finance calculations or interest calculations. So this is one of the very important functionality of built-in functions. Now, these are all number functions, right? Let's start looking at some of the character functions, or let's say any string functions. So what we'll do is, first of all, we'll start with the basic stuff. Let's say select length length of some given string. Let's say, for example, I will give what is my name is the string and from dual. So what will happen here is if you run this, it is going to tell you what is the length of this string. So these are like string functions. Now, same thing we can apply like the input length of ename. Let's say ename in the employee table. And you can see here all the lengths will be same because there is one issue. If you look at the employee table description, we defined ename as a character data type and it is not a varchar data type. If you look at the employee table here, you can easily see if you click here, it shows that the employee name is a character data type. Now, what if we look at, let's say, we created phone book. Phone book has person name, which is a varchar data type. Now, in case of varchar data type, this length will be varying. So let's take a look at select length of, let's say, person underscore name from phone book is our table. So if you look at this, now you will see there is a different length. Probably there is all the data is like same length. Let me look at the data also just to understand why it is showing 3 for all of them. Yeah, here our names are same. Let's say phone number, phone underscore number. Okay. And also let's select this phone number so we know to compare. And unfortunately all phone numbers are of the same format. But you get the idea of, let's say, length can be used on a string and it will tell you how many characters are there in the string. Like first example here, you can type anything here and it will tell you what is the length of that given input. Okay. So length is a very important data type. I mean the function for strings, and I will proceed with the remaining examples and then I will explain how they can be used together. Now, what we'll do is in certain cases you want to have a fixed length output. Okay, so let's say for example I'll show you here. Um, let's say I want string displayed. Okay, my name is, and I want something after that. Let me just first run this. Okay, this is how it looks like. Okay, now if you want to make this total length of, let me just make it like that, and I'll say this string, what is the length of this? Okay, it is easy to figure out by writing a length function. Now, what I want is the total output should be 20 characters. Let's say, for example, I want to pad, and what is the character I want to pad it with? Okay, so pad it with, let's say, for example, star. Okay, now this is lpad is left side, and you can see here what we are doing is we are forgetting to specify the final length. Okay, I will run this and then explain. Now, what we are doing here is this is my input. I want to make it look like 20 characters at the end. And if this is not enough length, then pad it with stars to make it look like 20 character length. Now this will become 20 character length because it added some stars here to make it look like 20 character length string. And you can do the similar stuff by padding it to right side. So you can see here, first time I'm doing a lpad, second time I can do a rpad. And here you can see the first one has a left side padding, second one has a right side padding. Okay. What you can do is you can combine these two things into one larger function. Let me just say you want to lpad it to make it 20, and then you want to also rpad it to make it a length of 30, let's say. Okay. But this time I want to right side, I want to pad it with $, and left side I want to pad it with a star. Let me run this and show you the example here. So first what it is doing is it is taking this inside one. It is making the input, given input to 20 characters by padding it to stars on the left side and then dollars on the right side. And then final output will be 30 character length. So total output. Okay. So this is a very interesting option when we use it. lpad, rpad are very interesting because they can be used for providing graphs and stuff like that. What I want to show you with the employee table is, let me show you one example of employee table. And also we know that it is ename column. So ename and length of ename. Okay. Now here in this case, we know that the ename column is of character data type. And even though you have variable length, it is just showing one length because of character data type. What it is doing inside is the king has only 4 characters and then 6 characters are just empty spaces. What if you want to remove those spaces? So for example, you can do a rtrim, and rtrim is right trim of ename, and also figure out what is the length after you trim it, length, and you can see here. Okay, first of all, what I'll do is ltrim. Okay, and I will copy this. Hold on 1 second. Copy this and paste it again. And instead of ltrim, I'll do rtrim. Okay. So here, what I want to show you is, first of all, first output is just ename. Okay. Second one is length of ename, which is 10 because it's a character data type. It has spaces padded inside. Now then we said length of ltrim of ename. Ltrim is left trim, meaning if the given input, if there is any spaces on the left side of the given input, those spaces will be removed, and then find out what is the length of it. Now, for the given input on the left side, there is no space, only on right side. So that's the reason here for the length of ltrim of ename, it gives the same output as regular length. But if you see the last column, we're asking it to find out by removing all the spaces after the given input and then find out the length. Now it gives you exact length of king. So you can see here, this is how you can remove the spaces if they're already there in the data. Okay. So any questions, let me know. Otherwise, what I'll do is I will show you one grand example after putting everything together. I will show you one example at the end. Okay. So then what I will do is I will show you how to change the the data inside this column are all in uppercase, but we can play with the data inside the ename column. Let's say ename, upper of ename. Okay. Same way we can do lower of ename. And also we can do a initcap of ename. And when we look at the output, let me run that and then explain what is the output. This is your original data, what is stored inside the table. Now, if you make everything uppercase, it might not look different because it's already in uppercase, but you can ask it to make everything lowercase. That is the function here, lower. And then there is a initcap function which makes the first character uppercase in every word. So if you had 2 words, then every letter in the first letter of the word will become uppercase. Let's say, for example, I will say select in single quotes. I'll say from dual. Okay. In the single quotes, I will say I am walking. So that is my sentence, and I will say initcap just to show you what happens with this. Every first letter in the every word becomes uppercase. So you can see here I became uppercase, A and W became uppercase. I am walking is the, and you can look at the output how it became first letters in every word became uppercase when you use a initcap function. So this is how you change the given data from uppercase to lowercase or lowercase to uppercase or things like that. Now, there is another very important function called substring. So let's work with substring a little bit. What we'll do here is let's say I will remove this. I am walking in the beach on the sand dunes. So something like that. I have a long string, okay, and I want to do a substring. Okay, substring is basically you're taking a small portion of the string and displaying that output. So let's say, for example, whatever is the length of the string, I want to take from, let's say, fifth letter. I want to capture 2 characters after fifth letter. So if you run this, what it is going to do is, let's take a little bit longer sentence. Start at the fifth position and take 4 characters. So now remember that you give your input as the first one is the input string, and then second parameter is where do you want to start within the input string. Let's say fifth position. So let's count fifth position, first position, second position, third position, fourth position, fifth position, and actually fifth position is the W. And how many characters do you want to pick? Okay. Um, Sorry, here what happening is there is a space also in front here, which you cannot see, but when I copy it, you can see the space. Like here, there is a space. Okay, so fifth position is this one. So 1, 2, 3, 4. Fifth position is a space, and it is picking 4 characters after that. So it picked space WAL is the output. Okay, so that's how you can pick number of characters. What Oracle does is in the substring function, what if you specify you want to start at fifth position and you don't specify anything else, then Oracle will automatically take it to the end of the string. Starting from the fifth position, it goes up to the end of the string. Also, Oracle provides you a way to do minus values, meaning start at the end and go 5 spaces negative. Let me run this command. And then what happens is instead of starting from the starting, it will start from the end and go backwards five positions, or that's what it is doing right now. It goes 5 positions backwards and picks up those characters, whatever is the output. Okay. So you can play with this substring function. It is a very important function. It is used a lot in production systems. Now earlier I showed you something with the lpad, rpad, ltrim, rtrim, all that stuff. What I want to show you is there is a very interesting thing you can do. Let's say, for example, you look at select star from EMP table, and what you can do with this functions is, now let's say, for example, you want to know the employee name, name, comma salary. Okay. And what you can see here is this is how the output looks like. But what if you want to construct a graph of this without using any graphics? You want to show a graph of salary, like which person is getting highest and how is the salary graph. So what you can do here is I want to show you a very interesting way of doing this. First of all, what you do is, let's say you want to figure out what is the salary and also divide that by 100. Let's say salary by 100. Okay, that is the first thing you want to figure out. Okay, then if you see this, it is going to give you some output here, salary by 100. Now you're just converting it to something you can handle. Then what I want to do is I want to show stars. If there is 50 salary, that will be 50 stars. Okay. Now bear with me for a second. Let me write this. Okay. I'm going to lpad, or let's do a rpad. Okay. Write pad, and let's start with a star, single star. Okay. And pad how many stars you want to pad. And what do you want to pad it with is a star. Okay. Also, I will not start with a star, but I will start with an empty string like this. Okay. When you run this command, what you will see is, sorry, here I have to specify a star. So let's just do that. And when you run this, you can see there is a nice graph output. You can see this is a simulated graph output, which shows each person's salary as a graph. Okay. So this is one way to use the rpad. What we are doing here is we are converting the salary into a 2-digit number, which is contained, let's say for example, 0 to 100 is the range. So you are converting that to a 2-digit number. You start with 1 star and then pad n number of stars to make it of this length. Okay. So for every salary, you see here it will draw 50 stars, here it will draw 28 stars, here it will draw 24 stars, and so on. So here it will draw only 9 stars or maybe 10 stars because we started with 1 star. But in any case, this is how you can use the string functions. All of the functions are very useful. So don't underestimate the power of any function. All functions are very useful, and they can be used in certain situations where you can get interesting outputs when you use them properly. So knowing how to use each function is very important. And also, as I said, we just discussed about few string functions here. There are a lot of other functions. Now, so far, since we started our whole discussion, we never used dates properly. So let's play with some dates. So first of all, now we are going to start talking about date functions. So we'll say dual. Okay. And what I want to know is what is the date today? What is the current date? Let's say sysdate is the function in Oracle which tells you what is the current date. So you can see here current date is 25 Jan 2016 or 16 here. So the default format is DD MON, 3 letters of the month, and YY. Now this can be controlled on how you want to see the output. You can change it. That can be controlled. Once we learn the character functions or conversion functions, we'll look at it. But for now, what we'll do is we'll just play with whatever is the default format of the date. Okay. Now what happens with the date is, now you're asking select sysdate from dual. Let's say I want to add 5 days to this. Okay. Now also I will say what is the current date, and then the second output is how many, if I add 5, what happens. So here you can simply see when you add 5, it added 5 days to the current date. Okay, so that's how you can do some math with the sysdate. Now let's say for example you want to add months, Now in general, let's say for example you want to calculate car payments for finance, you have to calculate the interest. So what is the today's date? And you're giving a 30-month loan, let's say for example. So what you will do is today's date is this date, and you are going to add months. How many months are you going to add? Let's say 30 months. Okay. So if you do this calculation, you can see if you add 30 months, what will be the new date? That means this is the end of the loan date. Okay. So this is how you can calculate by add months. Okay. If you are adding 5 days, this is a 5-day loan, then you can do just 5 days. But if you are adding months, then you can do how many months you want to add. You can provide as a second parameter. Okay. Now this is one function. Now let's say for example we know 2 dates. Let's say for example we know I will provide, let's say for example, the date of hire was 10th January, let's say January like this, 2014. Okay. And what is today's date? Let's say sysdate. Okay. Now I want to figure out how many months are in between this date, these two dates. So there is a function called months between. And what it does is it tells you exactly how many months, and because every calculation also has some hours left over, so those hours are represented as decimals here. But what it is telling you, if you want to round it, what you'll do is round, and you'll say round it to 0 decimals. And what it is telling you is approximately 25 months is how much a person worked with us. So let's say, for example, if you put sysdate in the front, then you'll get a positive output, positive number output. But let's say you are asking a loan started on 10th January 2014, how many months have passed so far? Okay. So if that is the calculation, then you are basically, you can do this months between function, and it is very useful to tell how many months are passed so far. Okay. So here we are doing like say, first of all, we did a sysdate. We did some simple math by adding some days to it. Then we said add months to the given sysdate. We are also finding out how many months are in between two dates. Round was a general function we learned with mathematics with the number functions. We are just using that here. Um, so these are some of the very important functions. Now, let's say, for example, this is a very important function. I'm going to introduce something called last day. Okay. So what is this month? Let's say what is the sys date today, right? And what is the last day of this month? Okay. Sys date. So if you do this, you have to provide a date function here, and a function name is last day. So what is that we are trying to do here is, let's say you are taking a loan. Okay. Now this loan will expire sometime after some time. But what is the last day when the payment should be reaching the loan company, let's say? Now, in that case, you can figure out by doing, let's say, for example, sysdate, you want to add, let's say, you got how many days? Let's say 380 days. They gave you a loan for 380 days. Sysdate plus 380 days will give you what output? Let me figure that out first. Okay. So this is how you will do a calculation. Let's say, for example, today is 25th January, that is sysdate. Now sysdate plus 380 days, that is the loan period. So loan is ending on 8th February 2017. Now you got, you're giving a permission to the customer to pay it on the last day of the month. Okay. So what you're doing is last day will tell you what is the last date a customer can repay his loan. So if you see, like say for example, this year is a leap year. So if you do a last day of some date, let's say for example, I'll give February 20th February 2016. And also let me put it in this format. Okay. So here we don't have to know whether it is a leap year or not, what month it is. Last day will automatically calculate what is the last valid day of a given month. Okay. So here what we are doing is, with this function, we are asking what is the last day for payment for the loan. Okay. So in your calculation, in your application, you have to do this several times, and you can run this way, and you'll be able to figure out what is the last day in the last valid day in the given month. Okay. So this is very useful when you're doing finance and then interest calculations and certain things like that. Now, same like last day, there is another function called next day. Okay. So let's say, for example, what is today? Today is, today is this 25th January 2016. And I can say, what is a next Monday? Okay. Let's say, for example, what is your input date? Input date is sysdate, let's say. Okay. Now, today, ignore that it is Monday. Let's say, for example, I want to figure out what is next Wednesday. Okay. So I will say Wednesday, like 3 days, three things. So if you look at the calendar, the next Wednesday is on 27th. Okay. So what you're doing here is next day, you provide a three letters for the day you want to search. Let's say, for example, you want to figure out what is next Sunday. Okay. This is also very useful, like it tells you what is the exact date of next Sunday. This is very useful. Let's say, for example, you want to say you got a loan for 360 days. Okay. I mean, 380 days. We were looking at the previous scenario where loan is provided for 360 days. Instead of saying I want to pay on the last day, I want to say after 380 days expire, what is the first working Monday? Okay. So on that day is your last day for payment. Okay. I want to show you the difference between, we did the same thing with the last day. So I want to show you the difference here. So let's say, for example, you want to do a last day of the month. Okay. What you're saying here is, first thing, I will write some comments so that way you can know. So we got a 380 days of, we giving 380 days of loan, 380 days of loan, and repayment is last day of that month. Okay, when it expires. So if you want to calculate that, right? So then this particular situation, you're giving a 380 days loan, but repayment is on next working Monday. Okay, next Monday, let's say, for example, next working or not. So in this case, if you look at this, this is how it looks like. So if your business says you can repay on the last day of the month, then you can use this function called last day and generate the last date. Or you can say I'm giving you 380 days, but repayment is on the next Monday when the 380 days finish. 13th February 2017 is the day instead of 28th. So because now you're not doing any mathematical calculation on your own, you're actually doing the date based calculations. It will be accurate and it will always pick the right date, meaning it will look at the validation and all that. And leap year, often people forget about leap year. So that kind of errors will not creep into your code. So Oracle provides lots of date functions. We looked at few of them. Um, Knowing what is available will be very helpful. So then you can apply all these functions together and then do a lot. Now, next thing we are going to talk about conversion functions. These are very important to understand how we can convert from one data type to the other data type. And also here we are looking at a standard function of, let's say, date always returns you day, month, and year in YY format. But if you want to change this format so you can see the time, because I told you Oracle in the date data type also contains time. Let's say, for example, how do I get current time? So that we can use conversion functions for that, and we'll figure that out tomorrow. So we'll continue tomorrow evening at 7:30 again. So any questions for now? Okay, cool. Thank you very much.